What we're going to do today is learn how to balance an equation using the ion-electron method. The reaction is going to be balanced in an acidic medium. Today we are going to balance a reaction between oxalate ions and permanganate ions. C2O4 2 negative is the oxalate ion. It's a reducing agent with MnO4 minus, which is the oxidizing agent. It produces carbon dioxide, and Mn2 plus. Oxygens usually change into water, and if the reaction takes place in an acidic medium, we can add hydrogen ions on the side that is deficient in hydrogens. In order to balance the equation, the first thing we need to know is the oxidation numbers of elements and identify those elements that are undergoing a change in oxidation. So we are going to find the oxidation number of carbon first in oxalate ions. There are 2 carbon atoms, therefore it's 2 times X, the unknown oxidation number, plus 4 oxygens times -2, the oxidation number of oxygen. The net charge of the oxalate ion is -2. So 2x minus 8 is equals to -2. 2x is equals to plus 6. X is equals to plus 3. So the carbon, for one carbon atom, the oxidation number is plus 3. Let's look at the oxidation number of the manganese ion in manganate. MnO4 minus, Mn is going to be X, so X plus 4 times -2 is equals to -1. There are 4 oxygen atoms. -2 is the oxidation number of oxygen atom, which is also the common valency. So X minus 8 is equals to -1. X is equals to plus 7. So we have the oxidation number of carbon plus 3, manganese plus 7. In the product side, the oxidation number of carbon is going to be, let's look, CO2. The net charge is 0. X plus 4 times -2. 2 times -2 is equal to 0. X minus 4 is equals to 0. So X is equals to plus 4. So you have oxidation number plus 4 for carbon and carbon dioxide, and manganese has an oxidation number of plus 2 in the product side. So carbon changes its oxidation from plus 3 to plus 4, so that's the oxidation half reaction. Manganese changes from plus 7 to plus 5, therefore that's the reduction half reaction. Separating the 2 half reactions, we will write oxidation half reaction. The oxidation half reaction involves oxalate ions changing to carbon dioxide. Now the element that is undergoing change in oxidation is carbon. If there are 2 carbons on the left, there should be 2 carbons on the right. Always balance those elements undergoing change in oxidation first. So if you look at the oxidation number now, for one carbon atom is 3, therefore 3 times 2 is plus 6. And now in the product side, 2 times 4 is plus 8, which means when 2 carbon atoms in oxalate changes to 2 molecules of carbon dioxide, it produces or gives away 2 moles of electrons. So we have balanced the oxidation half reaction in terms of the number of electrons that are lost. Reduction half reaction MnO4 minus gives you Mn2 plus. Here it's plus 7 changing to plus 2. For this change to happen, we have to add 5 moles of electrons. And incidentally, the number of moles of electrons produced in the oxidation half reactions is 2. And the number of electrons required is 5. So it's an even number, an odd number. When you have such a case, multiply them by the coefficients for each of these to make the number even. So you're going to multiply the oxidation half reaction by 5 and the reduction half reaction by 2. So now you have plus 7 times 2 makes it plus 14, which means we need 10 electrons, and here that will give you 2 manganese ions and makes it times 2 gives you plus 4. Rewriting, so we have 5 C2O4 2 minus giving you 10 CO2 plus 10 electrons. This is the oxidation half reaction. The reduction half reaction, we have 2 MnO4 minus plus 10 electrons giving you 2 Mn2 plus we need to balance the oxygen now. 4 times 2, 8 oxygens. 4 times 2, 8 oxygens, therefore makes it 8 H2O, which means we need 16 hydrogen ions. 8 times 2, 16, so we also have to add plus 16 H positive to balance the hydrogens in the water molecules. Adding the two equations right now should give you a completely balanced equation. So we would rewrite it as 5C2O4 2 minus plus 2 MnO4 minus plus 16 H positive gives you, the electrons are cancelled because they are common, 10 CO2 plus 2 Mn2 plus 8 H2O. You have a completely balanced redox equation here, and we have used the ion electron method. The equation is balanced in an acidic medium. If you count the charges on the left and the right, they will be the same. So this is how you balance a redox reaction using ion electron method.